All right, here's a couple of settings. So we've talked about VLAN settings, remember that? We talked about, so we did VLAN, we did the setting for, what else did we do? The spanning tree, we did a setting for that. Seems like we would have more settings than that so far. I guess we don't. Well, here's the next one. The next setting is going to determine when does the switch start resending the frame. Okay, so we're worried here, or we're interested here, if we look at the frame, remember we had the preamble, we had the start of frame, and right here we start the destination address. It makes sense that as soon as the switch knows the destination address, it might start sending it. Okay, so that quickly. As soon as it gets to the destination address, it immediately goes into the other port, it looks it up, and then it starts sending out the new frame immediately. This is going to be the fastest thing. This is fastest, so we start resending it immediately. We call this a cut-through address. Okay, so this would be the fastest you could cut through. The second one is if you go down a little ways, we have the source, and then we have what they call tags. And one of the tags is the VLAN ID. Okay? If we're using VLANs, we have to cut off here, because we need to know not just the destination, but we have to know what their VLAN ID is. You all remember the VLAN stuff, right? Where we were dividing the network around. So we need to know, as a switch, you need to know what VLAN this is on, because that's going to determine where it goes. This is going to be the cut through if you're using a VLAN. Okay? So you've got to go all the way through the VLAN ID. This is not very long, by the way. Okay? So notice here, we're getting very early in the frame here before we cut through. Okay? If we're going at a gigabit per second, we're not very many bits into the frame before we cut through, and not very many more bits to get here. So you think here maybe this is going to add a tiny bit of latency. It is only a very little bit. This is, microseconds or nanoseconds of latency, the difference between this and this. Okay? But we can cut through later. There are some times, where are we at here? We get into the tags, there is a length field. We have the data. And at sometimes we're going to go all the way through sort of the data-ish. Well, we'll cut through down here. This is when we're worried is if it is not a runt. A runt is just the frame is too short. So the switch will read the frame and making sure it's long enough before it will pass it along. So if there's enough bits in it for Ethernet, we're going to catch some errors. Okay, so we just make sure it's not a runt. The last thing we would do is we could cut through. This is that error checking field, that's CRC. And the last thing we might do is see if there's no errors in it. Okay? Long enough for Ethernet, there we go. The last thing we call this is store and forward. Okay? And a store and forward mode of the switch means it's going to read the whole frame and make sure it's all there and it's all good before they forward it to whoever the destination was. And you guys can see these range in the amount of latency it's going to add, right? So the destination address is the fastest you can go, period. VLAN ID adds a very small amount of extra latency. Checking the length adds just a little more latency. And then this one adds the most because you're going to read the whole thing, you're going to check for errors, that takes a little bit of time, and then you're going to forward it on. So store and forward. It does add a tiny amount. It is, overall, this is usually 7, and I think micro is that funny little U, microseconds, for a cut through. And store and forward is about 60. Is that the right one? It's the symbol. Micro might be the other U. Anyway, I'm trying to write micro. Now you guys are like, he's no nerd. He doesn't know what the symbol for micro is. Anyway, micro, whatever it is. It's like, looks like a U. So it's not a lot of difference. Remember, usually latency, we worry about milliseconds. On a LAN, though, 60 microseconds is something. I mean, it's not nothing, but it's not going to affect anyone's voice or anything else. And certainly this stuff won't do, isn't going to kill your latency. And just to note, by the way, you're only going to do these long ones is if you have a bad link. Only on... Okay, and you can set this by port. Did I say that here? You can set this by port. So I can go in, and if I have a port where the wire or the cabling was bad, and so I get a lot of bad frames, I can set just that port to be store and forward. So that means the switch isn't going to forward junk along. And that's actually pretty normal, because you don't want the junk clogging up the rest of your network.